Hello guys. So let's quickly treat work energy theorem. Work energy theorem. Now, work energy theorem states that the work done by a force acting on a body. When a force acts on a body, the work done by that force during the displacement of this body, when this force is acting on this body, during the displacement of this body, the work done by that force is equal to the change in the kinetic energy of the body. You know, when a body is moving, let me say a body is at rest. This body move from point A to point B. Sorry, where's my duster? Let me say this body moves from point A to point B. Initially before it starts moving, we can say it possesses what? It possesses potential energy. But when the body begins to start moving, it possesses kinetic energy. As it continues moving, the kinetic energy is changing, right? Why the potential energy is also changing. So till it comes back to this point and stopped. The kinetic energy keeps changing, keeps changing. So the change in the kinetic energy, do we get? Like as this body is being moved by the application of this force over this displacement. So that change in kinetic energy is equal to the work done by the force. This force is actually doing a work on the body to have moved this body from a point A to point B. So, in a nutshell, the work done by a force acting on a body is equal to the change in the kinetic energy of the body when the body undergoes a displacement. Do we get that? So now, in another word, we can say when a body in motion is acted upon by a force, like a body that is moving, just like I explained earlier. When a body that is moving is acted upon, or when a force is acting on a body that is not at rest, a body that is moving, maybe from one point to another, let's say body, when a force acts on it, the kinetic energy changes. Are we together? By an amount which is equal to the work done by that force. Do you get what I am saying? In a nutshell, when a body in motion, which I've displayed, moving from this point to a particular point, let's just say from a point A to point B. So as the body is moving, the change in kinetic now, because position is changing, are we together? Because position is changing, or let me put it this way, because velocity changes rather, because initially it was at rest. Yeah, it was at rest. Our velocity is 0. And when the body starts moving, the velocity is no longer 0. So there's a change in velocity. And because there's a change in velocity, there is a change in kinetic energy. Yeah, since the mass remains the same, we are still referring to the same body. The mass is the same thing. So because velocity changes from rest to a particular velocity, so because kinetic energy equals to 1 over 2 mv squared. Now, because this v changes from 0 to something, or from not just from 0, it may not actually be from rest. It may be from a particular velocity to another velocity between the 2 points. It depends. So because the velocity changes, what happens to the kinetic energy is changes. So there's a change in kinetic energy, sure, between the 2 points. Now, when that body that is in motion, you know, it's an application of force on the body. So the change in the kinetic energy of the body is equal to the amount of the work done by the force acting on the body. So in a nutshell, there's no need to stay long on this. Just say change in kinetic energy is final kinetic energy minus what? Let's say final here, mv initial kinetic energy. Are we together? So which is also equal to what? Work done. That's what we are saying in essence. That is, if a body has an initial velocity of vi and a final velocity of what? Vf, the change in kinetic energy is written in this formula. which is equivalent to work done. And we can transform this to something like, so we can say our work done now equals to 1 over 2. 1 over 2m is common to these two. Here we now have what? V final square minus what? V initial square. Do we get that? Now let's move on to the next thing. Let's solve a few questions. There is no much to do. Where's my notes? Okay. Just give me 2 minutes. Okay, let me pause the video so that I can write the questions. Now, a 6.0 particles, a 6.0 kg particles has a speed of 2 meters per second at point A and kinetic energy of 7 joules at point B. A. Find kinetic energy at A. Kinetic energy at A. No, we are not asked to find change in kinetic energy. We are asked to find kinetic energy at A equals to 1 over 2 m v a square. Velocity at A, so which give us what? 1 over 2. What's the mass? 6 kg times 6. What's the velocity at point A? 2 meters per second at point A. 2 square. And that's what? 1 over 2 times 6 times 4 equals to 1 over 2. 6 times 4, 24. 24 divided by 2. That's what? 12 joules. So can KE at A equals to what? 12 joules. Let's keep it aside. 12 joules. We've kept it aside. Now, question B says, find its speed at point B. Now we have been given KE of 7 joule at point B. So, KE at point B equals to 1 over 2 mvb square, isn't it? And we have been given KE at point B to be 7 equals to 1 over 2. What's the mass? The mass is 6 kg times 6 mv, and sorry, 1 over 2 mvb square. So this gives us 7 equals to 6 vb square over 2. Are we together? Do we get what you are doing now? So here we have K equals to half mvb square. So here cross multiply, we have 6 vb square. 7 times 2, 14. Right, so here we have vb square equals to what? 14 over 6, isn't it? 2 here, 7, 2 here, 3. So vb square is 7 over 3. That means vb equals to root what? 7 over what? Root 7 over 3. So our velocity at B, vb equals to root 7 divided by what? 3 meter per second. Let's also keep that aside. Now the last question, the total work done as it moves from point A to B. Don't forget our initial definition of the work energy theorem, is that the total work done on a body when a force is applied on that body is equal to, as it moves a displacement, is equal to the change in kinetic energy of the body. So our work done, total work done equals to change in kinetic energy. And what's change in kinetic energy? 1 over 2 m v square, v final square minus v initial square. So which is what? 1 over 2. What's our mass? 6 kg into, what's the v final? Point B is the final. So the speed at point B that we found earlier is what? Root 7 over 3 square minus, what's the speed at point A? 2 square. Do we get that? So this one now give us 1 over 2 times 6. This one will remain 7 over 3, isn't it? Because the square will cancel the root. So here we have minus what? 4, isn't it? So here equals to 1 over 2 times 6 into, the LCM here is 3. This gives us 7 minus this over 1. 1 in 3, 3. 3 times 4, 12. Are we together? So here now, we are going to have, there's no problem. So here we are going to have something like, I'm coming. It's not bad. I'm trying to check something why this is going to give us negative, but there's no problem. Actually, the original question, the mass is 0.6. Yeah, so instead of root 7 over 3, it should have been root 70 over 3 because this is actually 0.6. So you shouldn't have gotten negative value. This should have been 70 over 3 greater than 4. But we have 7 there. But there's no problem. Let's continue. If we have the work done to be negative, that means, how can I put it? Should we say the work done opposes the motion? Something like that. Yeah. But there's no problem. Just get it straight how the solution is being done. So there's no issue with that. So I just want to confirm why I'm having negative here, which is not a taboo. It's not an abomination. So there's no problem. But the original question is 0.6. So this would have been 70 over 3 instead of 7 over 3. So here we have 7 minus 12, which is what? Minus 5. So this becomes 1 over 2 times 6 into what? Minus 5 over what? Over 3. Are we together? So here, what do we have? Don't forget, we've gotten our final velocity to be root 7 over 3 meter per second. Our KE at point A to be 12 joules. Now we need the total work done. So this gives us 1 over 2, 6 times minus 5, minus 30 over what? Over 3. 2 here, 1, 2 in 30, 15. So this gives us minus 15 over what? Over 3. And total work done is what? Negative 5 what? Negative 5 joules. Do we get? Negative 5 joules. That means the work done is in opposite, it opposes the motion because of this negative sign. Take note of that. So that's that for that. So now, here is another beautiful question. A 3.0 kg object has a velocity of this. The velocity is given in vector form, so we need to find the magnitude. So how do we find the magnitude? Let's say V initial going to give us root square the coefficient of I, c square. We go and watch my video on vector to get out to this magnitude. Minus 2 square. You square the coefficient of j. So this gives us root c square is what? 36, right? This one is 4. That's what? Root what? Root 40. I think that should be 2 root 10. Yeah. Root 40 is 2 root 10. Yeah. Yeah, that's that. Because root 2 is 2 is root 4. Root 4 times root 10, that's root 40. So that's our V initial. Now for the V final, 2 root 10. So for the final okay, now before then, we've gotten the magnitude of the V1. Now the question says what it is kinetic energy at that time. At that time, when the velocity was still 2 root 10, we got this magnitude to be 2 root 10. So what is the kinetic energy at this time? So Ke at that time, let's say initial Ke, because for this one, initial velocity equals to 1 over 2 m. What's our m? 3. 1 over 2 mv square, 2 root 10. Okay, let's put root 40 there, no problem, because it's going to be more wonderful. Root 40 square. So this gives us 1 over 2. Root 40 square is 40 because square we cancel root. 3 times 40, that's 120. Isn't it? Divided by 2. So that's what? 60 joules. So we have 60 joules aside. 60.0 joules as the initial kinetic energy. Now, the question continues by saying, find the work done on the object if velocity changes to. Now, let's first find the magnitude of the final velocity. Final equals to square root of the quotient of I is 8, square it, plus the quotient of j is 4, square it. So here we have root 4 square is 16, 8 square is 64, 64 plus 16, that's 80. 80. So now first find the final kinetic energy before we find the total work done. So Ke at final equals 1 over 2. Our m is 3 times root 80 square. That's 1 over 2 times 3. Root 80 square, square cancel root, that's 80. 80 times 3, that's 240. 240 divided by 2, that's 120 what? Joules. So we have the final kinetic energy to be 120.0 joules. Are we together? So what's the next thing to be done now? The next thing now let's find the total work done. Don't forget, total work done equals to change in what? Kinetic energy. And our change in kinetic energy is Final kinetic energy minus initial. That's 120 minus what? 60 equals to what? 60 joules. So that's our total work done. Now, this is another beautiful question. 12 Newton force with a fixed orientation does work on a particle as the particle moves through three-dimensional, 3D, three-dimensional displacement. This is the displacement. So first thing we need to find, let's find the magnitude of the displacement, square root of the coefficient of I here, square it, plus coefficient of J here, square it, plus coefficient of K here, square it. So this gives us root, this is 4 plus 16 plus 9 minus 4 squared is 16. 16 plus 9, that's 25, plus 4, that's what? 29. So our D here, the magnitude is what? Root what? Root 29. Let's keep it aside. So now what are we asked to find? What is the angle? Don't forget, we are given change in kinetic energy. And don't forget that work done equals to what? Change in kinetic energy according to the work energy theorem. And under vector, we know work is a scalar quantity and we know the formula. Okay, we don't need that. We don't need that. Don't worry. Don't worry. Yeah, it's a scalar quantity, of course. But we know this is FD cos. Because I use this formula under vector, that's why I'm just trying to vibe saying something like that. FD cos theta, we all know this, isn't it? And are we given force? Yes, 12 Newton. So our work done is what? 30 joules. So 30 joules equals to F 12. What's our D? Magnitude. Root 29, isn't it? Cos what? Cos theta. Is that clear? So here now we are going to have cos theta equals to 30 divided by what? 12 root what? Root 29, isn't it? 6 here, 2. 6 in 30, 5. So what happened? Cos theta equals to what? 5 divided by 2 root what? Root 29. So at the end of the day, we get something like, we are going to get something like cos theta equals to 0.464. 5 over 2 root 29. Press in your calculator, that gives 0.464. So theta equals to cos arc cos of what? 0.464. And that gives us something like, I think that should be around 62.3 degree. So that's the angle between the force and the displacement, 62.3 degree. Now, this will be the last question. A single force acts on a 3.0 kg body. You can say kg particle-like object, whatever is there. Whose position, once the mass is given, there's no problem. Whose position is given by this. Now, no work done equals to what? 1 over 2 mv square minus u square. Or you say v final minus v initial, right? So, but we are given position, not velocity. Since we are given time too, so we can find our velocity. But our position is given in terms of function of t. So, what do we do? If you differentiate, velocity equals to dx over what? dt, isn't it? If you differentiate position with respect to time, you are going to get velocity. So if you differentiate 3.0t, you get 3.0 minus, if you differentiate 4.0t square, 2 times, this will come down. I'm going to watch my video on calculus. Yeah. This becomes what? Minus 8t. If you differentiate this, 3 times 1, this gives us what? Plus 3t square. Yeah, if you differentiate this, get 3 minus 8t plus 3t square. So now, to find our v initial, because the time is 0, substitute 0 here. You have 3, this one becomes 0, 0. If you put 0, 0, 0. So our v final is 3 minus, if you put 4 here, 8 times 4, 32. If you put 4 here, because the final time, put it. 4 square, 16. 16 times 3, that's what? 48. So here we have v final equals 3 minus 32. This plus 3 minus 32. That's 29, right? That's minus 29. Is it okay? Let's start with this. Minus 32 plus 48. That gives us 16. if I'm not mistaken. If you add 16 to this, you get 48. Yeah, minus 32 plus 48, that's 16 plus 3, that's 19 meter per second. This one also meter per second. So our V initial is 3, our V final is 19. Just differentiate the distance or the displacement, the position with respect to time. Whatever I get, substitute the initial time, it gives initial velocity. Substitute the final time to the same thing, it gives final velocity. So if I substitute t here equals to 0, I'll get 3. If I substitute t equals to 4, I'll get 19. But don't forget, you have to find the derivative first. So 19 and 3. So our work done now equals to 1 over 2. What's our mass? Times 3. Final is what? 19 square minus initial is what? 3 square. So our work done equals to 1 over 2 times 3. 19 square. 3 square is 9. Now let's check for 19 square. 19. Let me quickly pause the video and quickly work that out. Yeah, I was able to obtain 369. Whether it's correct or not, punch your calculator. I will explain what is necessary. 1 over 2 times 3 into 369 minus 9. That's 360, right? 2 here 1, 2 in 360. 180, isn't it? 180 times 3. 100 times 3, 300. 80 times 3, 240. So our work done equals to what? 540 joules. See, 2 here 1, 2 in 3 is 180. 180 times 3 times 1, that's 540 joules. So that's the work done. Thanks for watching. Don't forget to like and subscribe. And you can also subscribe to my channel membership. Yeah, you can just click the button there. You see something like join. You can join. Well, I place the least price that you can ever see on YouTube on it. It's just 1,000 naira per month. So that's where we do our like private class for students. So you can prefer to join. And in fact, there are some videos I can even post because we just started actually. And one of the aim is that there are some video I can even post on my public videos, my YouTube public YouTube, and I may decide to give assignment on my private channel for those who subscribe. So they will have access to a lot of things. Though we just started. But this week, I think you can be watching this video later in the future, maybe in years to come. But right now I'm talking now, this today is 16th of May, 16th of May 2026. So I'm saying this week. So it depends on whenever you are watching it, so you know that they would have done a lot on that channel, on that private channel. Let me subscribe. So whether you are watching it 2 years to come, they would have done, even though if you are watching it in few days to come, because you are actually going. I've started few things there which it's kind of powerful. So even in 2 days or even a day, between today and next tomorrow, we are going to do like a lot, really lot on the channel membership. So I will advise you just subscribe now before it's too late, so that you won't miss. Because as the assignment becomes more and more, it becomes bulky and bulky, and you wouldn't like to be solving a lot of things. So it's better you subscribe now. It's just 1,000 naira per month. Yeah, it can be free, has been ordered by YouTube, but I place the least price on it, so of which it can be very much affordable for you. So even this particular work energy theorem, I may decide today to even put like 10 questions there for my channel membership to solve, and they will send the assignment where it needs to be sent to, and I will also do solution. So try to subscribe to the channel membership. It's just 1,000 naira per month. You can click on the button there, join, and if you have your bank card, just subscribe. Thanks for watching, and don't forget to like and subscribe to this general channel too. Share the video among your friends if you actually gain something, and drop your mind on the comment section. Thank you. See you in the next video.